and we do have another speaker who is already on the call. Ananya, feel free to unmute yourself and do join us. I know you're joining us from Washington. Thank you so much for being with us today, Ananya. We can't unmute yourself. Yes, perfect. I can hear you now. How are you today?
I'm doing good. How are you doing?
I'm doing really well, and I do remember the first time we met. It hasn't been that far, but the world was in a better shape, I felt.
Definitely.
Interact face to face. I know it probably wasn't really as well as we expected it to be, but right now, I think with the pandemic and everything that's happening, you know, we are where we are. We are connected via Zoom nonetheless, and we're very excited to have you speak about biases today. I was really looking forward to this talk because it will touch upon a topic I'm really passionate about, and having someone who I have already worked with in the past, and I'm so excited you've joined us already once as a mentor. You're in our Discord channel as a mentor as well from Microsoft, and so I'm happy you're joining us as a speaker this time to share something you have been working on in your professional life. So it's over to you. Do tell us all about biases in gender, and do teach us about what everyone should be mindful of, because obviously boys and girls are working on stuff. Some of it is quite sensitive, mental health and whatnot. Some are passionate about climate change or fake news, but everyone needs to understand how to work with data and how to ensure that the products that they develop is really well informed by the people they're designing it for, and at the same time, ideally try to, remove the biases or prevent them from, becoming the problem. So thank you so much. It's over to you now, and I can't wait to hear all about it.
Yeah, thanks for having me here, Elena. I'm really excited to be here and be speaking to all the awesome teenagers today. Let me share my screen, and can you let me know once you're able to see it? It's can you see my screen yet?
Not yet. Are you able to share it now?
I am able to share it.
Perfect. I can definitely see your screen now.
Okay, perfect. Hi everyone, I'm Ananya. I'm a machine learning scientist at Microsoft. A lot of my role right now includes making machine learning models to help the Microsoft sales and finance teams in order to figure out which customers should they target, and which are the customers they should go talk to first. And when they go talk to them, what are the things they should be selling to these customers? During my grad school, I did a lot of work around gender bias in language. So to figure out how, first being able to detect automatically when a particular context in the language is gendered, or if there are a couple of sentences which are really gendered, and what is the amount of bias in those sentences. So I know we've already had a talk around racial bias. So today I'm going to focus really on gender bias. Now, gender bias is all around us in the world, everywhere. Kelly just spoke to us about some of the areas for machine learning research in healthcare. And there has been a lot of work around machine learning in healthcare, which has surfaced issues because of the biases. Even if you look beyond machine learning, so in clinical trials, for example, for the medicines Solidin, we observed that it had higher health risks for women. And now one of the reasons for that turns out to be the fact that during the clinical trials, there were significantly larger number of males in the clinical trial compared to females. So now the drug is really tuned well for males, but we did not know of all the effects or all the negative effects that might be greater for females since they were not represented well during the clinical trials. Another example is if you look at the voice assistants. So whether it's Alexa or Bixby, Cortana, Siri, all of them have female names. I'm sure a lot of you must have observed it by now. The voices default to female voices, and they do also have programmed flirtatiousness in them. Now, all of this reproduces and like exaggerates the stereotypes that exists around female secretaries, as well as the fact around the fact that in general, the secretaries that you will see in office are females. Now, given that we have gender bias in the world around us, it does obviously creep into machine learning and artificial intelligence as well. Back in 2018, if you used Google Translate to translate a sentence from English to French or Spanish, and if your sentence was "I'm a nurse," you would get a feminine translation. While if your sentence was "I'm a surgeon," you will get a masculine translation. Now, you don't have this problem in English because your pronouns or nouns and words are not gender inflected. But basically, when you're translating to French or Spanish, which are gender inflected words, you can see the bias that the machine learning algorithm has in there. Back in 2018, Amazon was using a recruitment algorithm to filter out the resumes that it was receiving for the job applications. Now, what people observed is that within this algorithm, it would automatically downgrade the resumes, which either had like the word women in it or had a women's college associated in it. And the reason for that was that the machine learning algorithms, which formed the base of these recruitment algorithms, were trained on historical data. And this historical data had a preferential treatment for male candidates, just because unfortunately, because of the way our society has been. Now, this is another example of a use case that we use machine learning for. So if you look at the first example here, what the machine learning algorithm is trying to do is, like, given this pronoun, so your sentence is the physician hired the secretary because he was overwhelmed. And what the algorithm is trying to do is figure out if this he refers to the physician or the secretary. What we see is that when this pronoun, when we have a pronoun which is referring to physician, the machine learning algorithms predict it, like make this association correctly when it is a he. But when it's a female physician, the algorithms are not able to make this association correctly. Similarly, in the second example here, we are trying to find if it is connected to the word secretary, and the algorithms are again correct if it's a female secretary, but when it's a male secretary, the machine learning algorithms are not able to get this association well. In another paper, so this is actually some of the work me and my advisor did in grad school, when I was in grad school. And what we were trying to look for is basically after you train a machine learning algorithm, what are the common words, phrases, or contexts it links with males versus females? And what are the differences that we see there? What we observed was that the machine learning algorithms think that words like soft, blushed, giggled are common for females, while they would associate something like nominated, grinned, etc. with males. Similarly, a phrase like corresponding secretary or dressing room would be associated with females by the machine learning algorithm, while a phrase like partnership is associated with males. When we gave the machine learning algorithm a context which basically talked about how someone was like really dressing and what their looks were like, the algorithm thought that we were talking about a female. While when we were talking about someone who might be an orator, writer, or a thinker, the algorithm thought that we are talking about a male. Now, an obvious question here is, what is happening? Like, why are these machine learning algorithms reacting in this way? Where are all of these biases really coming from in the machine learning algorithm? And for that, it might make sense for us to do a quick recap of how do the machine learning algorithms really work. So how do machines learn? So machines learn in a way which is very similar to how we learn as humans. So the way I would learn to play basketball is I would try to throw the ball. I might fail, and once I fail, I repeat the process. I try to understand why did I fail the last time, and I make some changes to my strategy and try again. I might fail again and then I try again. So I kind of repeat this process. And that is what the machine learning algorithms do as well. So if you look at the figure on right, the points in blue is your raw data. And the line in red is your machine learning algorithm. And now what the machine learning algorithm or model wants to do is fit this line in such a way that it is the best approximation to the trend that we see in this data. So it starts from the play being like a completely horizontal line, and it slowly moves towards being a good fit to this data. So what is basically happening is that this model is trying to learn existing trends from the existing data. What this also means is that if you give your model bad data, it is going to learn something which is not right. So if you give it something garbage, it will learn something garbage because it's trying to learn what you give to it. And another thing that can also happen is that, let's say what you give to the model is good, but your model is bad. In that case also, you will get really bad results. So what is the problem with our machine learning algorithms? First, the data that we are giving to the machine learning algorithms to learn is biased. And this is because of the way things have been in our society over time. For example, historically, there have been more men who were doctors compared to women. So when you train a model on historical data, be it like newspapers or novels, the model will see more men who are doctors compared to women. Again, historically, women have assumed the role of cooking in house. So if you look at pictures that you might find in various data sources, there are more pictures pictures with women doing the act of cooking compared to men doing cooking. So what it means is that, let's say when I train my model on this data, since I'm giving the model biased data, it is going to be a biased model because in the data it sees that, okay, only 33% of the men cook. So it will never think that more than 33% of the men might cook in the real world. The other problem is that the machine learning models not only learn the existing bias in the data, but they also exacerbate this bias by overfitting on the data that they are given. So going to the example that we just saw, when the model saw only 33% of the men to be cooking in its training data, what it finally learned was that only 16% of the men are cooking in its algorithm. So it's basically a twofold problem. There has been work done to address both of these problems. So you can your first approach could be to improve the quality of the data that you train your model on. So this would basically address the issue where you don't have enough representation of both the genders in your data set. The second approach could be that you don't really change your training data, but you fine tune your trained model so that once your model has trained and it's a biased model, you remove this bias from the trained model. So one of the examples of the first approach where we want to improve the data set is a data augmentation technique. So what some folks did was given given a biased data set, they generated an auxiliary data set. And what they did was they replaced all the male entities with female entities, and they replaced all the female entities with male entities. Now they combined the original data set and the auxiliary data set and train a model on top of this combined data set. This combined data set has equal representation of men as well as women. So the model that gets trained is not biased. However, with this approach, there are some limitations as well. For example, let's say you were to blindly do this substitution and train your model on it. There might be a sentence in your training set which says that she is pregnant. Now, what your model will do it, because it's just doing these substitutions, it will replace the she with he. But a man cannot be pregnant. However, since you're doing this substitution, your model will learn that both men and women can be pregnant. So this creates the issue that while what we want to do is remove the unwanted bias, what we end up doing is we end up removing even the differences that we would want the model to learn between the two genders. Another issue with this approach is that it's really difficult to generate new training data set or to acquire new data, since a lot of it requires human involvement, and that makes it an expensive process as well as a very time-consuming process. So the other thing that we can do is we don't change the underlying data, but we make changes to our model and the model training in order to reduce or remove some of these biases. So one of the things that we do is we can introduce additional explicit constraints on the whole corpus. And the corpus here is basically our whole data set, to say that the distribution that the model sees in training data set, it should not change it after the model has learned. So let's say if during training the model saw that there are only 33% men who are cooking, then even after training, it should not send that 33% to 16%. It should still keep it at 33%. While this is not the best case scenario, it is better than exacerbating the bias that the model is seeing in the data. In order to tackle the challenge of the fact that we don't even want the model to learn that only 33% of the men are cooking, but what we rather want is for the model to learn that both men and women are equally likely candidates to cook, we'll look at a different approach of debiasing word embeddings. And for that, let's just look at what word embeddings really are. And word embeddings are a really powerful technique in the field of natural language processing. So the field of natural language processing is basically whenever you are trying to learn anything from text data, it falls in natural language processing. Now, how it works is basically a word embedding is like a multidimensional representation of your words in a high dimensional vector space. So in here, I have a plot which is just three-dimensional, since humans have difficult time visualizing anything greater than 3D. But what we try to do is, let's say you have a word helicopter, you will get a vector representation for this. And since it's 3D here, it gets mapped to 0, 2, 4. Similarly, your drone might get mapped to 0, 3, 3, and so on. How these work is in two ways. First, these word embeddings are able to detect semantic as well as syntactic relations between words and phrases. Secondly, they also help us group similar words together. So going back to the first point, which is really important, what they can do is help us identify the relations between, let's say, so if you take the vector king, subtract the vector man, and add the vector woman to it, it will give you a word embedding which is close to queen. So if we look at the first figure here, what it is saying is that in this high dimensional space, the direction between king and queen is the same as direction between man and woman. So in this way, the word embeddings are able to represent the meaning of gender in them. Another example is your second figure. So in here, the direction when you go from walking to walked, is same as the direction when you go from swimming to swam. So in this case, the word embeddings are capturing the direction of the tense of your verb. A third example is the relationships between countries and capitals. So using the word embeddings, you can automatically identify what is the capital of Spain, given you know the capital of Italy and the name of the country itself. Now, how do word embeddings go wrong? So what happens is we observed in the data that when you look at the relationship between doctor and man, the word embeddings think that this relationship is same as the relationship between nurse and woman. So again, these word embeddings are learning from the historical data. So they might be learning from the articles in the newspapers or our novels or Wikipedia articles. And what it means is that in our data, we have the word doctor associated more with men compared to with women. And nurse is associated more with women compared to man. If you look at this diagram here, the dots highlighted in blue are the professions that the word embeddings associate with females. And the dots in red are the professions that word embeddings associate with males. What we see here is that the word embeddings or the machine learning algorithms trained on using word embeddings think that women are generally your designers, librarians, bookkeepers, or hairdressers, while your bosses and captains will be men. So, how can we remove this bias from the word embeddings? What we do is, say here, this is a two-dimensional representation of the same word embeddings. And what you see is that the word babysitter is much more on the left side when you look at the bias direction, which is your X direction, while the word doctor is on a higher spectrum of your bias direction, making it a male word. So what we do is we change the coordinates of the words babysitter and doctor such that in the direction of bias, both of them have the same coordinates. So we map both of them to this axis so that their X coordinates become similar, while their Y coordinates will still be same, which means that in a direction which is not related to gender bias, in a gender neutral direction, there is still some difference in their meaning, which we want to retain because a babysitter and a doctor do not have the same task to do. But in the direction of gender, they do not have any difference, which means that now if we do anything using these word embeddings, then that algorithm will not differentiate between a man and a woman for these professions. Another really cool tool that has been developed in order to reduce or remove gender bias is the Slack plugin. And what the Slack plugin does is, as you are typing a message in Slack, it will automatically try to identify the unconscious bias that might be in the text that you are writing. And it will also make suggestions about how you can improve what you are writing or reword it so that it is not a biased sentence. Since like a lot of times we are not like consciously writing a biased sentence, it's just unconscious biases developed over time. So this tool helps us to remove those biases. There are a lot more solutions as well as problems in this space, but I think for today I'll stop with this. I do have like two things I would really like to encourage you guys to do. First is, it's really important to be aware of the fact that these biases do exist in the system, because if we are not aware about them, we would never think of doing something about it. So once we are aware of it, it's half the battle won. And once you're aware of it, as all of you build your applications or websites or algorithms now during the workshop, I want you all to be proactive about what are the sources due to which the biases be it gender biases or racial biases, might be creeping into your algorithms. And also to test your algorithms, once you have trained your systems, I want you to test your algorithms to make sure that you're able to recognize if there is a bias in these trained algorithms, and if there is, what is the extent to which there is this bias, and if there's something you can do to remove it. It could be something like, let's say, when you are doing surveys to collect the data, making sure that you have an equal representation from both males and females, so that you have good data. Another thing is, it has been shown, like research has shown that the teams which have lesser women in them come up with, like, end up building systems which are more gender biased. So if we can have more representation from females, that would really help us automatically being able to, like, being more proactive about this and being able to develop better algorithms. And I think one of the places this is also evident is in the fact that, as Elena shared, right now in the top machine learning researchers, less than 20% of them are, less than 12% of them are females. So we really need to make sure that we are able to improve that number and have more representation from females at all levels of machine learning. Thanks, everyone. Happy to take any questions.
Amazing. Thank you so much, Ananya. I love the last slide, the Q&A, the pugs. So Ananya, I would just love to know, how did you get into machine learning? Tell me a little bit about your personal journey and where did it all start? Why did you choose, data science and machine learning? What was the inspiration?
Definitely. Thanks, Elena. And it's actually pretty interesting. So my undergraduate was in mechanical engineering. And after I finished my undergraduate, I decided, like, I was not really interested in mechanical engineering by the end of it. And so I went on to CERN in Geneva for doing a software engineering internship. And it was a 6-month internship. And during my internship there, I think around after 2 months of my internship, they had a conference, a data science and machine learning conference about doing machine learning in the field of natural sciences and physical sciences. And they had invited people from all over the world, and it was a 1-week workshop. And I attended it just to, like, learn more about what's happening there, and I was, like, just amazed by everything there. And after that, I found a colleague while at CERN who was also interested in machine learning. And back then, Kaggle was a pretty new platform. So Kaggle is a platform for where you can solve machine learning problems, and they post, like, challenges publicly, and a lot of people solve them, and they even, like, share their code when people are solving it. So you can look at their code to get help, and they have a lot of discussion forums as well. Anyway, so we did a machine learning problem there on Kaggle. It was around an insurance use case. And after that, I got really interested. So once I finished my internship, I came back to India and I joined a startup which was doing deep learning in the space of healthcare. It's called Cure.ai. So there I worked on a problem which was around being able to scan knee MRI images using machine learning algorithms and like telling what is the extent of osteoarthritis in the patient. So when a doctor does it, one, we need an expert doctor, and two, it takes them at least 15 to 20 minutes per scan. So we developed an algorithm which would take like 8 to 10 seconds per image to do the same scanning and giving the result. So that is where I got like really interested. So during all of this part, I got really interested, and then I came to States for my master's plus PhD program, which was focused in machine learning and deep learning. So there I worked on deep learning applications in the area of like high energy particle physics, and then I went on to doing deep learning for natural language, and that's when I started looking at gender bias in language.
Wow, that's amazing. And what did you study as a teenager? What was the inspiration for you in maths and sciences? Because we do have a trend of a lot of girls in particular dropping their maths at A levels and just not as interested in sciences or maths as you would be in Russia, in India, in China. I'm not entirely sure why that is the case, but what would you, recommend, and what was your inspiration? How did you keep going and persevering with apparently such a difficult subject that the maths is, that a lot of girls for some reason assume? I certainly did not convince my daughter to not drop maths in A level, and I know many girls do. It's an option they do often in the British education system, to choose specific subjects and drop others. And whenever there is an option to drop maths, that's the first subject it goes, apparently. Your experience and passion.
I think for me, I always loved maths and science as a child, and for me, like since I was a kid, the I was like I either want to become a doctor or a scientist. Those were the only two things that I like really thought of doing, and I loved maths because of the way how it's like so precise and there's like a logic to everything. Compared to like other fields which might not be like which might have like a little bit more ambiguity. I guess like I like the little bit more of the precision side of things. um, Another thing that really helped me was that my parents always encouraged me to have a growth mindset, which means that like whenever I faced a challenge, it was never like, oh, I can't do it. I always thought of it as I can't do it just yet. All I need is more practice. So the phrase that if there is something you can't do, it's just like you can't do it just yet, but there is nothing stopping you from doing it in the future. And all you really need to do is they keep doing, keep practicing, and then you can literally do anything and everything.
Oh, that's fantastic. Great support from parents. So we have a lot of young people here who are in that mindset, and obviously we all want to get them to know that they can do anything they want and anything they set their mind to. What would your top tips be to these young people? It's the first time they're exploring AI and data science. It's the first time they're even trying to understand what human-centered design is. Why is this really important? I've had some already ask me, oh, this is like such a long process. When can we start coding? And it's, how do we keep them motivated, and how do we make sure they believe in themselves and we know they can do it, but how do we get them to know that they can achieve anything they really want to achieve?
I think first thing I want to say is that like I'm just amazed by all of the teenagers that we have like in this program. Like when I was their age, I did not really have a clue of like what machine learning is or AI is. So I'm just amazed by their brilliance and their dedication and perseverance. I think like the fact that like they are watching this video or they are in that workshop means they're already like way ahead of where I was when I was their age. So I'm sure like they will do much better than me when they are like my age. Secondly, uh, I think like I'm sure it might be like overwhelming. Like right now, all of this might be overwhelming for all of you, and I want you to know that it's normal. Don't feel like, please like don't feel like, oh, this other person is like doing it better than me, or oh, they are like I'm not able to do as well as they are doing, so maybe I'm not good enough. We all have our own learning curve, and while the other, you might not know, it might be very overwhelming for the other person as well, and it's okay. The fact that it is overwhelming just means that you are learning. It should not, it should definitely be like more encouraging rather than being demotivating. And whenever you feel like, oh, this is really hard, or like, oh, I don't know how to do it, like think of it as a learning opportunity. The fact that you don't know how to do something or you're having a difficulty means that there is more for you to learn. And I would like always rather be in a space where there is more for me to learn rather than being in a place where I already know everything and there is nothing new for me to learn.
Perfect. Yes, I always encourage them to come to this program with the mindset, I know that I know nothing, but at the same time, know that really everything is possible, and there is nothing that is impossible. But it's always great when it comes from someone else who is where you are right now at Microsoft. And so obviously for a lot of the young girls on this program, you are, their inspiration, their role model. They want to be where you are. They want to do what you do. And so I'm really grateful that you have come today to share your story and the presentation as well. So everyone who's watching right now, I hope they are mindful when they ask questions, when they create those surveys, and they're also mindful when they start developing the algorithm. So I know you will be joining us in Discord as well, and I can't wait to see what will happen to your team, because I think you're mentoring one team or two teams. How many have I given you? Two teams, yeah. So they're very lucky to have you, and yes, it will be incredible to see what will happen on the 7th of August. I'm really looking forward to that. So Ananya, thank you so much for that today, and I will see you in Discord. And we do have our third speaker here, who I know I did not announce earlier because it was meant to be a surprise. So Ananya, we'll see you later. Thank you so much.
Thank you.